Hello everyone, welcome back to the module 3 session 5. As usual, I'll be just briefing you about the syllabus which we have covered and the operational amplifier of module 3. Introduction to operational amplifier, um, op-amp input modes, op-amp parameters such as CMRR, input offset voltage, input offset current, input bias current, input and output impedance, sleeve rate, gain bandwidth product, unity bandwidth, then total harmonic distortion and the transient response. We recently saw in the previous session about the sleeve rate calculation. Till now we have directly deal with the op-amp parameters. Okay, hope all these sessions from session 1 to session 4 very interesting. Next, having known the concept of an op-amp, the definition, its internal architecture or the block diagram, and the cross-sectional view, then different various types of the parameters. Here we are just going into the end of the op-amp syllabus. Okay, that is the applications of op-amp. In the applications of op-amp, here it can be applied to any real-time application where the heart of the component uses or out of the circuit uses the op-amp. What I mean by heart of the circuit means the main component involved in the circuit is the active component which they are using as a operational amplifier. Okay, some of the applications of the op-amp are an op-amp can be used as an inverting amplifier. The operational amplifier can be used as non-inverting amplifier, voltage follower, adder, or it is also called as summer integrator, differentiator and comparator. Okay, these are the few applications. Other than these applications also you have many varieties where this is just limited to this syllabus point of view, that is 18ELN14. One by one we will look into it. The first one is the inverting. These are the op-amp application which I had briefed you just now. The first one it's called as a inverting amplifier. An inverting amplifier, also known as a inverting operational amplifier or the inverting op-amp. It is a type of op-amp circuit which produces an output which is out of phase with respect to its input by 180 degree. Why? Because the input is given to the inverting terminal. Hence, the input voltage, however, is being given here, you can observe here, is get inverted and the output is getting inverted and which is out of phase and it is with respect to 180 degree inversion. In this inverting amplifier, circuit, the operational amplifier is connected with the feedback. What is mean by a feedback? Means the input, that is here the inverting terminal is connected to the output through a resistor, and that resistor is called as the feedback resistor. In an inverting amplifier, the operational amplifier is connected with feedback to produce a closed loop operation. When dealing with the op-amp, there are two ways, two very important rules to remember about the inverting amplifier. These are, first rule, these are no current flows into the input terminal. No current flows into the input terminal, and that V1 is always equal to V2. However, in real world or in real application, op-amp circuits, both of these rules are slightly not used or slightly broken. This is because the junction of the input and the feedback signal. Here the feedback signal is X. This is called as a virtual earth summing point. Virtual earth summing point. Okay. This is because that the junction of the input and the feedback signal X, the feedback signal X is at the same potential as the positive input. Here this positive input, positive means the non-inverting input, which is at 0 volt here, which is at 0 volt, because this is at grounded. Okay, and this junction is called as an virtual earth. Because of this virtual earth, a node is been created. The input resistance is Rin of the amplifier is equal to the value of the input resistor Rx or this Rin value only, and the closed loop gain of the inverting amplifier can be set by the ratio of the two external resistors. We said just now that a virtual earth or a summing point is created. At this particular virtual earth or a summing point, no current will flow into the input terminals, and the differential input voltage is 0. That is V1 is equal to V2 is equal to 0. That is the virtual earth. These are the two important points to remember when we are discussing the inverting amplifier. And in this type of the inverting amplifier, output is produced which is out of phase with respect to input, that is of 180 degrees. Okay, next coming back to another type of application, that is a non-inverting amplifier. In the non-inverting amplifier, it is just opposite to your inverting amplifier. It means that the non-inverting amplifier is one in which the output is in phase. See here, the input and output are inverted. I mean the output is inverted with respect to input, but here the output is same as your input. So this is called as the inverting, and this line should be joined here. In the non-inverting amplifier, here an amplifier that produces an amplified signal at the output having a similar phase, same phase as of input is known as your non-inverting amplifier. This simply means that for an input signal with a positive phase, the output will also be positive. It means from 0 to 180, the input is positive. The output from 0 to 180 or 0 to pi, also the output is positive. This means that there will be the same phase. The non-inverting amplifier is one in which the output is in phase with respect to the input. So likewise we can tell that the feedback which is being applied to at the inverting input, the feedback which has been applied at the inverting input will help the output to be in phase, okay, with respect to the input. In this we can see that the input voltage signal Vin is applied. Here the input voltage signal Vin is applied to the non-inverting input. Here see, Vin is applied to the plus input terminal, that is a non-inverting terminal, which means that the output gain of the amplifier becomes positive in value in contrast to the inverting amplifier circuit. We just saw this previously, that is in contrast with the inverting. We just saw in the last discussion, okay, whose output gain is negative in value. This result, the output signal is in phase with the input signal. Okay, this feedback resistor, what that RF does is, here is achieved by applying this is achieved by applying a small part of the output voltage signal back to the inverting terminal. Okay, via or through this feedback resistor RF. The voltage divider network, this voltage divider network again producing a negative feedback. This closed loop configuration always produces a non-inverting amplifier circuit, which will lead to good stability, a very high input impedance. So by using such type of the circuit, we can have a good stability and very high input impedance. Input impedance means that Rin is tending towards infinity, as there is no current flowing because there is no input applied. The input is applied only to the plus terminal. Okay, so and ideal condition, input is very high, input impedance is very high, and output impedance is very low. Okay, very high in terms of infinity, and the output impedance is very low. So the waveform for the inverting and the non-inverting can be compared, and most important thing, you have to tell how much it has been changed, that is out of phase or in phase. This is at 0 degree deviation, but this is at 180 degree, the output is 180 degree deviation from the input. So these are the two op-amp applications of inverting and non-inverting amplifier. For references, we have just taken a few websites, as well as I told you, you can refer to any prescribed textbook, and you can see that how the input and the output, the changes with respect to the inverting and non-inverting amplifier. Not only that, you can just have a derivation of any equations also, that is the relationship between the RF and R1 also, like that also you can see. Okay, so for more details, you please refer to any previous textbook or prescribed textbook. Okay, thank you.